Hello everyone, welcome to Pedia, and today I'm going to discuss about which is the first thing that comes to a structural engineer's mind, that is dead load. Dead load in any building structure. This is a very critical element. Sometimes dead load is that critical that even the live load is just 25% of this. So before going into detail, one thing that I would like to share is that I've uploaded one blog on the website, that is www.structurepedia.in. There you can find the densities that of building materials. Also you can find the unit loads and the area load that we generally have in buildings, which is very easy for an engineer to design. So you can just use that area load and you can design a building and quickly calculate the loads on beams and columns. So first, before going into detail, so what are the things that I'm going to cover in this video is I will take a basic layout of a building, a very simple building with beam and column and slab. And the other thing that I'm going to do is I'm going to calculate characteristic and ultimate dead load that are applied at the base of the columns at level 1 of the structure. So I'm going to discuss what is level 1 and level 2 and level 3. So let's first draw it. So if you haven't watched my previous video, just go and watch how I sketch without using any scale, how I sketch a building, which is very useful because the proportion and aspect ratio is the key aspect to make sure that your design looks good when you are explaining to someone. And if your aspect ratio is not good, it looks very funny images. And even if you are talking to a client or trying to explain to your professor or anyone else, and you just draw funny pictures like with the dimension like 3 meters 4 meter, which doesn't look like 3 meters 4 meter, and a person will simply laugh on that, thinks that he will think that you are not good with sketching, so you are not very good with proportions. So this is really important to convey your idea. The best thing to convey your idea as an engineer or maybe an architect is to draw. If you're good in drawing, then you can very well explain your concepts and your visualization and your imagination into paper. So let's first draw what the schematic diagram of a building, and then we will calculate the loading of that building at the base of the column. So I'm taking a very light pencil for now, and then just so the span of this building is 8 meters. So I'm just first drawing, let's say this is roof level. So first level, draw center line, then 1 2 3 4, 1 2 3 4. That's okay. So this is my column center line, this is my other column center line. So let's draw a center line of this link so you know it, which is the center line, and based on that you just plot other two center line, which is center line of the columns. So this is my column location, this is my other center line. This actually represent the center line of the column. So I'm just writing column here as well. It's very easy. Okay, now let's lay let's say this is the top floor. This is top top level of that slab, and now we need to draw a beam. So let's say this is my slab thickness. It would be very less because this span, this is 8,000 mil, which is 8 meters. That's right. And now you have some beam. I'm not showing dimension here. I will write it down separately in on the next page, so it is very much clear, and you can easily go through video again and again and to make note of it. If you want me to write down if you want me to upload this complete set of pages on the website, just to comment in the comment section, and you can just follow the video, as well as you will have a set of Word PDF document to refer anytime you want. Okay, so this is my beam, and I'm just shading beams so you know which is the beam area. Now this is okay. Now what are dimensions? So this is 350, this is 1200, and in this total is 750. So that means 400 mil is the downstand portion. So this is 400, which is downstand. Good. Now let's first draw column. This is my column. Great. It's my column as well. Similar to these things, you now what is story height? That is 3.5 meter. This is 8 meters, and you have assumed this as one division. Take this 1, 2, 3, 3.5. This is my other floor. Same. 1, 2, 3, 3.5. This is the other floor, and one more floor. It's 1, 2, 3, 3.5. This is one. Pretty easy. Same thing you have to do. You have to draw beam and slab, which is something look like this. That's okay. Yep. Okay. Great. So now beam dimension and everything is same. Now it's better to show that with color. So which is your beam portion, which is your column. So this is your beam. Great. This is my beam again. Now this is my RCC column. This is slab. This is downstream. Let's say this is beam. Downstream portion. So I'm just marking. It's the same thing for our structure as well. Now we got dimensions. So also we need to mark up this dimension. This we have in margin. This is 3500. This as well 3500. This as well 3500. Great. Now one thing is clear. Now we have columns, we have beam, we have slab. Everything is clear. Now you have to mark the levels. That is, this is level 1, this is level 2, this is level 3, and this is level 4. Now we need to calculate characteristic and ultimate dead load that are applied at the base of the columns at level 1 of the structure. Great. So this is the level 1. We have to calculate the base at this base. So here we have, let's say, one big beam, right? And you have one column right here. You need to calculate this base. What would be the ultimate and characteristic load? Right? Easy thing. It's easy if you got a quick command on calculating things. So I'm just drawing a 3D view how it would look like. So let's say this thing take this way, and maybe this would be the area of the slab, and there might be a beam going like this. Good. This beam. Maybe this one, and you got I'm drawing in 3D to make you feel how things are there, and so we don't make mistake where we are calculating. And here we have, this is a column center line, this is my column at the top, so this will look like this. Okay, other thing is this. We show some thickness of the slab. So this is a 3D view to get a picture. Now, how many stories are here? For example, we have 6 stories. So total 6 stories. To this building above level 1, right? So column are used, square column. Dimension is 400 mil by 400 mil. Is a grid, so the building grid sizes. Grid size is what is a column to column spacing, because we have multiple columns in the building, so it might be, if you look in the plan view, so it would be some spacing. So this is something like this. So here we, in this particular building, it is something similar to like this. This is all 8, and this all 12. So this is this is our main target. This is the key thing, that here we have to calculate the loading. So grid size, write down the grid size, which is 8 meters. Generally we don't have this much symmetry in any building except it's a commercial building, In residential building, you have lot of staggered columns and beams. This I will discuss later on, where I will discuss some of our past projects. I will discuss the conceptual design that I have done for a building and how to select beam, where to select beam, where the bedroom layout, toilet layout, kitchen. You need to be very much careful with the levels, and there are a lot of things that. So it's not that easy to fix a conceptual design, but once you have done that, it is very easy to go towards the detailed design. So yeah, let's start with dead load first, and by after some videos like 15 to 20 videos, I believe that you will get a good amount of knowledge from it, and you would be able to apply that knowledge in your professional world. uh, okay, so you have mentioned the grid size. So level 2, 3, 5, 6 have raised floors and suspended ceilings with services installed within them. So 2, 3, 5, 6. This is 2, this is 3, and above that we must be having 5, 6. This 2, 3, 5, 6. 2, 3, 5, and 6. This is suspended ceilings. Okay. What do you mean by suspended ceilings? First of all, so if you have this slab, and generally you might have seen that we have ducts going. It might be air conditioning, or it might be a sprinkler system. So generally we fix a hanger from the top. We have a clamping plate, something like that, like this, and yeah, this is steel rod hanging from the top, and above this steel rod we actually support the ducts. So this is the suspended ceiling system. So this is additional load that is carried by the slab, which is a service load. So this is service load. Okay. Now other thing is that, so 2, 3, 5, 6 have such system, and if you know that level 7 would be the roof. So but there would be there also be suspended ceiling. In addition to that, there would be some top layering above that level 7, because since it's roof, that we need to provide the tile surface. There's additional flooring that we need to do on that floor, so we need to consider that. So level 7 is roof. So additional thing is 50 mil squid and 15 mil thick tiles. Okay. Now level 4. Level 4 is plant room. Level 4 is plant room, where you might be having machinery, but there is no finishes, because this raw room you can use it for the machinery. So don't really spend money on finishing the floor, but just a concrete floor would be sufficient. Or there won't be any suspended ceilings as well. At the level 5, that means level 4. So this is level 4. If it's level 4 and this 5, so there's no suspended ceiling at level 5, because we don't need any services in the plant room. Wait. So if there are building services hung from software of the level 5. Okay. Now I'm just summarizing these things into a simple way. Let's say this is my building. Okay. This is levels. Okay. Level 1, level 2, level 3, level 4, level 5, level 6, level 7. So this is plant room. Here we have tiles plus squid. Right. And in level 2, 3, so this is, if you have some suspended services, 3, 3, 5, 6, all of them we have, but we don't have anything in the plant room. Yeah. Okay, great. So first of all, we need to find out the self weight of the structure. So I'm going with the self weight of the structure. First of all, what is the easiest thing to calculate? That is floor slab. Floor slab self weight. What is the thickness of floor slab? This is 350 mm. So 0.35. What is the grid size? Is 8 by 12. 8 by 12. And what is the density of concrete? It's 25. If you don't know the densities, again I'm saying please do visit the website. There is one blog in which I have mentioned all the densities and all the basic aerial load, which is very useful in your entire life. I'm still using it, so you can use that. This is density of concrete. I'm just writing gamma concrete. Multiply that with 6 because there are 6 floors. Okay, 1 2 3 4 5 6, 6 floors. And because we are calculating at base of the level 1, this is actually, yeah. Okay, so this comes out to be 5040 kilonewton. You can use calculator. I have actually calculated beforehand so that it would be easier to in explaining more concepts rather than just doing calculation on calculator. So I haven't used that in this video. And this is band beam. You know why we call it band beam? Because the width is bigger and the depth of the beam is smaller. So you see this, how I have drawn. Generally people draw the beam like this with a huge depth and small width. This is a normal beam, but then band beam, this is bigger and this depth is small. This is the band beam. Band beam is more like a strip. A strip it looks like a strip, and the benefit of it is that you get a very lower depth in the beam, and it actually increases your clearance in the floor height. It's very useful, and this is very useful in designing the residential buildings because they are very classy and modern designs that are being developed in the residential buildings in recent years, and all of them, they want a very good false ceiling and different lighting system. And if if you have a very heavy beam hanging in just in mid of the room, then it actually spoils the entire interior and architectural view. So it's very useful to get knowledge of band beam. If you want me to discuss band beam in detail, then please let me know in comment section and I will cover that in a separate video. So now okay, band beam self-weight. You have included the floor slab self-weight. Now if you see, the band beam self-weight won't be counted from the top of the slab but only the downstand portion. So the diameter width of the band beam is 1.2 meter and total depth of the slab plus beam is 0.75. We need to subtract 0.35, that is top slab thickness, and now what is the length of this beam? So if you look at this grid, right, if you look at this grid here, you see how much is the length, 12 meters, right? This is 12 meters. So if you take the center line, because this part will go to this column, for interior there would be only 12 meter beam, 12 meter beam. So this is 12, again the number of floor is 6, this, and obviously you need to multiply that with density. It's come out to be 864 kilonewton. Great, we have done beams, we have done slab. What else we need now? We need columns. What is size of column? Is 400 mil by 400 mil, so 0.4 into 0.4. And what is the height? That total story height was 3.5 meter. We need to subtract the band beam and the slab thickness, that is 0.75, and you multiply by 25 the density of concrete and number of floors 6. This comes out to be 66 kilonewton. Great. Now so this part is done. Now other thing is that now services is really important, so we need to incorporate the services loading. It's very easy. So first we need to calculate where we have false link, where we have building services, those all things. So for now the basic things that I would like to explain is raised floors. Where you have raised floors, what I mean by raised floors is if you have any flooring above, because when you cast the concrete slab, you can't just start living on that concrete slab. You obviously have some marbles, you have some flooring. So the loading for the raised floor is 1 kilonewton per meter square. This is I mentioned in that blog, and also you just keep that in mind. Raised floor on 4 levels, that is 2, 3, 5 and 6. Okay, so 2, 3, 5, 6, because 7 we have roof, 4 we don't need anything, this plant room, so only 4 floors are left. So we need to multiply with that 1. The grid size is 12 by 8, and then you multiply that by 4. That's it. It's 384 kilonewton. Good. Now other thing is that from finishing and building services, so let's say now false links, where you are guessing where it should be. Let's go from top. 7 yes. 7, 6, yes. 5, no, we don't have because of this plant room. 4, yes. 3, yes. 2, yes. Okay, so they are total 5. So falling load is 0.25 kilonewton per meter square. This is also a key thing that we need to remember. So 0.25 into 12 into 8 and into 5. This is 120 kilonewton. Other thing is that you need to talk about the building services. What could be the building services? Building services might be ducting, water sprinkling. This would be the things. So what are the floors where we have that numbers? 2, 3, 4. We have 5. Yes, 5. No, because services is important. It's not like for living, but you need to have a sprinkling system and everything, which is mandatory in the entire floor. So all of them. So what is a load for building services? Same, 0.25. Okay, so it's 0.25 into 12 into 8, and then 1 2 3 4 5 6 6 more flex. This is 144 kilometer. Which thing we have missed now? Important thing, that is terrace roof. The roof we have two things: roof screed and tile finishes. So roof screed and tile finishes. I would recommend to refer one book, that is Structural Engineering Handbook. I've mentioned in some of my shorts and separate video, that was Tools for Structural Engineer. Why I would recommend that book is because there are a lot of materials that is used in buildings, and I can't list all of them in a video. It's always helpful to keep them handy and just make your own handbook and keep that handy, so you can use them wherever you want, and just like roof screed, tiles, marbles, wherever what are the basic loads that you are using in your designs, just keep them handy. So first, roof screed and tile finishes. So I'm just talking about screed and tile separately. What are the
1 second.
So screed, what is a thickness of screed? Is 50 mm, so 0.05, and density of screed is 24. The grid area is again 12 into 8. Again, the thickness of tile is 15 mm, is 0.015, and density of tile is 24. The grid span is 12 and 8. Okay, so this is 115.2 kilometer, and this is 34.6 kilometer. Adding all together, so total load at the base of level 1, base of level 1 column is, you add all together, it comes out to be 6768 kilometer. But this is characteristic load. What would be the ULS load? As per Eurocode, the load factor is 1.35, but if we use Indian codes, there the factor is different. I think it's 1.5. So it depends on country to country and the codes we are using. So I'm just talking about Eurocode now. So there you have 1.35. Multiply that load with 1.35. The value comes out to be 9137. So the actual force in that column is 9137 kilonewton. So this is how you list out all the things in a building, and you're very much sure about dead load and SITL, so you don't make mistake in this majority of load that building carries. That's all for today. Please subscribe, like this video, and if you have some special requirement in my video, then please let me know in the comment section. Thank you very much.